Okay, so the first algorithm that comes into the mind of any individual when they are trying to learn cryptographic algorithms, no? Because uh, it's DES that you have already heard. DES in 1970s introduced. Okay, somebody has to standardize that, right? Some standard body has to standardize. Then only we'll accept it, obviously. So NIST, National Institute of Standards and Technology, is a standard body which has published this algorithm, DES. Okay, after it's an output of a competition. Okay, and later in 1990s end, there is an advanced version of the algorithm that was world well known and being used now also. No security issues for that. It's AES, Advanced Encryption Standard. So generally, the name of these ciphers are not DES and AES. Keep in mind, it's not that. So there was some other names, but once it wins the competition, you give a standard name. It's called Data Encryption Standard. You just give a seal to that. Okay, and after that, there are some issues found with the size of the key with DES, which was a standard in 1970s, 80s. Of course, there's so much of controversy with the length of the password or key. After that, 1990s and new standard has come. Again, the same standard body has called for proposal. Please submit, design your own algorithms and submit. We are ready to evaluate. And finally, round one, round two, round three, the final round, if your algorithm still is resisting some common attacks, it will come to it will be called as, or it is the winner of the competition, and we'll give a name to it. It's called Advanced Encryption Standard. Okay, it's AES. We call it AES. Okay, so that was about simply symmetric key algorithms. So whenever somebody asks about crypto algorithms, that comes into mind is AES and DES, and they are the standard algorithms. Now, nowadays, people are using AES, but DES is out, it's obsolete, just not being used in any security protocols. Okay, network security protocols or anywhere, software offline, wherever it is, nobody are using it. Okay, that is one uh, uh, side of cryptography. It's simply called symmetric key cryptography. Symmetric because the key is both sides the same. Okay, I send something, I take a password, and you want the same password to read the message. Okay, as I told in the beginning, privacy is very important, not only today, even many years before. So that's why we go about designing new algorithms. Is that okay? So now after this modern this this particular generation, now from 1970s or 16, you can see the digital communication, right? Mostly you can see the communication has advanced a lot. Okay, and most of the data that we have is online now, right? Most of the data. Now this data that you transmit from one place to another place has to satisfy some needs. Okay, security, in terms of security. So I can call it a service. Maybe I'll call it as a security services, because I have some data I need to transmit from my device. Maybe it is a laptop or it is a mobile or whatever, to another laptop or maybe mobile a device or maybe whatever is on the other side. So obviously there is a requirement, a demand of a service from my side, because I don't want some of my data to be read by somebody else. Okay, the data can be anything. I can be an institution, I can be an individual, I can be a bank. Okay, it can be anything, right? I can be individual also, I can be a company or whatever. But still, data is data. Some data is very important. Nobody else has to be. Nobody should be able to read it. Is that okay? So obviously, some services will come out. So I just listed some services before we go into understanding, because this session is related with authentication. Authentication, the same English word. We know what is authentication. Okay, we are using the same terminology. Authentication. Okay, authorization. All these terms we already know. It's English frequently used phrases, right? So this authentication and some how do you provide authentication for the data that you want to transmit from one place to another place. So right, everything you are communicating online, the data is flowing from one place to another, being transmitted from one place to another place. The first thing what we require is nobody should read my data. That is the first demand, right? Or my first request that you give to some particular technical guy. Is that correct what I'm saying? Nobody should read, because your data should be private. Okay, and once that is satisfied, maybe because of some algorithms that is existing in literature, like what in the previous sessions you have learned, DES, AES. I will only use these two algorithms, DES, AES. There are many algorithms, let's not go into that, because they are standard algorithms I'll use. So if I want nobody to read my data, I'll just give a terminology to that. I'll call, then I have enough confidence that nobody is going to read my data. So I'll say that that service, I'll call it as confidentiality. That is the service. So immediately I ask my technical guy, please provide confidentiality to my data so that I can transmit over the internet or whatever, LAN or WAN or whatever. Then immediately I can say that please provide message confidentiality. Then immediately my technical guy will take some algorithms, existing secure algorithms. Okay, DS is obsolete, I'll not take that. My technical guy will not take. Obviously, AES will be chosen and some other variants of AES or maybe some other secure algorithms, block safer present algorithms which are secure will be taken into consideration, will be implemented, and whichever data I am transmitting from my laptop through the Ethernet or wireless, whatever, the data inside my laptop will be processed in such a way that it will be converted to some other data, okay, which is not intelligent, it has no meaning at all. So that will be transmitted over the internet, and for that what we are using, obviously we are using DS and AES, nothing else, right? DS, AES, not DS presently, but AES for sure. Even presently AES is being used. So no considerably important vulnerabilities are found or security issues are found with the AES algorithm till now, nothing like that. But if you have a very bad implementation of AES, that will cost you a lot. How to implement AES is also important. It's not that the algorithm is secure. Okay, that is one thing. So I'll call that particular service as message confidentiality. Okay, this is known to you in the previous session. We have already gone through that, right? Message confidentiality. So once that is over, again we are in the digital world, transmitting data over the internet. So that's not enough. Now suppose I am sending a message to you, what is the guarantee that I am sending it? One thing is sure, that nobody is reading it. Nobody is reading it. You are very happy that nobody is reading. But to the other side, to the other end, when he receives the data, there should be a surety, right? Sure, because everything is online. You are not seeing anybody else. Okay? We do not know who is sitting on the other side, who is receiving it. Okay, or the receiving person should know that whether I am sending it or not. Particularly when you do some banking transactions, no? Or when you get a link from the Flipkart when you're trying to buy a product. What is the guarantee that the payment you are giving to Flipkart or somebody else? Okay, or you're buying the product from Flipkart or some other site. And so this to solve this, you require a service, a new service I'll introduce here. When you are online trying to transmit some data, so I'll call it as authentication. Okay, so again, before I go into authentication, I'll also call something as message integrity. You know, integrity means what, right? You always the same English word. We have to keep our integrity and so on, right? So whatever happens, I'll not change my things. I'll be correct and so on, right? Whatever is my policy, I'll go accordingly. So nothing will influence me, something like that, right? So obviously, when the message is going over the internet, so if I am providing something called message integrity to the message, so the message is coming out of the laptop, I provide confidentiality, so nobody will read it. After that, another tag to that message, that is called message integrity. That means nobody will change the message. So if you are trying to change the message, even one bit of message, so it will make an alarm. Not alarm actually, but virtually what I'm saying is once it reaches to the other side, the recipient will understand something wrong has happened. It's not the actual message. Some changes has been made. Okay. First thing is he understood nobody read this because of AES being used. Confidentiality is achieved. But he should be sure that as a bit is not modified, even a bit, the smallest measure of information, no? Bit is the smallest measure of information. Okay. So even a bit is not modified. If that is the case, then again you have to come up with some methodology, a procedure, which you have to apply to the message which is ready here to be transmitted, right? You apply that particular methodology which is called message integrity. So there are some functions or methods that you can use to provide message integrity. So a little more, so message integrity is fine. That means nobody is able to change. If somebody changes, there is an alarm, right? So authentication has not come till now. Nobody can read it. Nobody can change it. People can change it, but I can identify something has gone wrong. I do not know who changed it, but I know that some bits are changed in the message. So this is fine. After that, the next demand, what I do is, sir, it's fine that nobody can read this message. I have the confidence, very nice. Some changes has been made during the transit. It can be intentional changes. It can be the changes happen due to the some noise in the channel, right? Some cuts or whatever, breakages of the wires, or maybe the signals getting issue, right? Because of the thunder strikes or whatever, the temperature, high temperature and so on. Okay, interferences and so on. Because of that also, the recipient will get something else. It can be because of anything, but we are only considering the case where intentionally somebody has changed the message, so we can still find. Third one is on authentication, where the authentication, as again I'm demanding, I should know who has transmitted the message to me, who is the person on the other side. So again, there should be, when I say who is the person, obviously I should get some identity of that person also, right? There comes the identity of the person who is sending it to me. A very nice application, I'll tell you. Whenever somebody says authentication, online transaction, etc., what comes into our mind? We'll never forget about this particular service, authentication. Okay, the client server communication, no? So like your browser communicating with WhatsApp server or maybe Google server or maybe any other web pages, no? It will have a server running background, right? So that client server communication, obviously there is a requirement of authentication. Okay, now I'll split the authentication. The authentication is a very important service since we are online, obviously, right? So that's very important. So so I'll divide that. I'll split the authentication into two parts. One, I'll say that that's a new terminology nowadays. One thing is data being authenticated, okay, and an entity being authenticated. Entity means entity is who is sitting on the other side. Okay, user being authenticated. Okay, user or entity or whatever I give the names. Okay, so sometimes on the other side it will not be a user. It will be a program which is automatically running on the other side. Okay, so it has to authenticate to me. Sometimes user will not sit. Okay, so it has to authenticate to me, or a user may be sitting, he has to authenticate to me. It can be a server, it has to authenticate it to me. So these are all users or entity or whatever. Now there is another split of authentication which is called data authentication. Okay, data authentication in the sense where the data is, it's not a little bit different from message integrity. When the data is, I'm a recipient of the data, I'll first of all see that yes, this is encrypted, nobody has read it, confidentiality achieved to the other person, fine, it is received. Now message integrity is also fine because I am verifying whether anything has gone wrong, any bits has been changed. Message integrity is fine. Now I want to know whether data has come from that particular IP address, from that particular source. Okay, so the data once reaches the recipient, he will say that, hey, I am the so and so person coming from so and so place. Understood what I'm saying? But entity authentication is little bit different, where now the data reaches, and after that you have to get a confirmation that yes, on the other side, who has sent the message. Okay, from the other side, from the particular institution, we do not know who has sent. Okay, now it's clear that from this IP address that particular message has come, but are you sure? Yes, from that IP address, who has sent it? Whether Saurav has sent, or myself, Srinivasan has sent, or somebody else, Arvind has sent, we do not know. But IP address is fine. I understood from where it has come. So data has authenticated. See the source IP address or whatever. See, a methodology that is being used to say that yes, I am coming from this particular source. So believe me, the data says. Then the receiver says that yes, I believe you, come inside. Now after that, what the receiver says is he want to know who is the person who has sent this data. Not in all applications, but in some applications it's required. Okay, so specifically you want who is that person. Sometimes it's not required, right? Because sometimes a group of people are authenticated. Any one of them can send the message. It's not required that who exactly in the group has sent the message. Okay, it depends upon the scenario, the application, so on. In some situations, exactly it is required who is that person. Okay, okay, is it SBI.com or it is Flipkart and so on. That server has to authenticate to you, to your browser. Actually, it is happening knowingly or unknowingly. Okay, your browser gets an information that yes, this the person sending the information. We are getting connected to this particular source. So we understood from the slide, the first slide, that there are some services that is provided by crypto services. One is confidentiality. These names are very important. Terminology is very important for us. Okay, so message confidentiality, message integrity. I add message to all of this. Message authentication, data or message, whatever. So data authentication, entity authentication also. Now, first question comes in, so very fine, you have put all these things here. Now, can you give some applications of this? It will be nice when you see the applications of different services. Okay, so nowadays message confidentiality only application is very difficult to find its it's always not suggested or recommended to build an application which only provides message confidentiality. Okay, you always keep the data integrity service, sometimes data authentication service also integrated with to this particular application, where both message confidentiality and message integrity, sometimes data authentication also is put together. Like for example, disk encryption, right? Offline it is. You have a software which encrypts your disk, which encrypts a partition, which encrypts a file. It's nice, right? Sometimes when you encrypt a file, I'll show that in the coming slide. Okay, practically I'll show you. I'll suggest a software also which you can use for encrypting your files in the laptop system, okay, computer and so on. So that's always important that your files can be anything, right? It can be video files, large video files, images, or it can be text, okay, or it can be anything that you have generated, okay, programs or whatever, exes and so on. So all these files you can encrypt it. Once you encrypt it, it is again another file, encrypted file. So the original file is there, the encrypted file is there. Now you can delete the original file. Okay. Now very important, if you used a very nice cryptographic algorithm for doing this, it's gone. So there is a password associated with this generation of encrypted data, which the cryptographers call it as cipher text. Okay, cipher text. It's a text only. Generally, we call it as a text. So, but it is a cipher text. Cipher is an algorithm which is used for generating cipher text. So, a meaningful message converted to something which has no meaning at all. Okay, if you are using a good, secure cryptographic algorithm, then this is true. Otherwise, from the ciphertext, I can get some meaningful messages. Sometimes get some distribution from which I will be able to find which algorithm has been used and which key was used for doing this whole process. Now, keep in mind always one thing I would like to say that. So, if you are going to design some algorithms, cryptographic algorithms, okay, it's not important that you design an algorithm and keep it secret. Like DES, AES, they are not secret, they are all public, right? Anybody can use, and AES is public from 1998, so it is some 20, 23, 25 years, it is publicly available. Till now, no vulnerabilities. Maybe very significantly important vulnerabilities are not found in AES. So that we can, anybody is encrypting using AES, they give me the ciphertext. I cannot read, I cannot understand, even I cannot break it, I cannot find the corresponding message. I cannot even find the password used for doing this process in AES. Okay, the password of AES, because generally I'm using password. In cryptographic community, people call it as key. So they measure the password in terms of bits. Okay, it is called 128 bits, okay, or 256 bit and so on. It's variable length. So if AES is using, if you are using AES with 128 bit key to encrypt your video data or audio data in the laptop, okay, obviously it is very difficult to do the reverse. You will not be able to get the message. You will not be able to find the right key also. If you get the key, it's over. Okay, and what I want to tell you is the algorithm used for doing this is public. You can buy, by general rule, you can say that the algorithm is public, only my password is secret. Something like no need to keep the laptops and everything secret, right? Or maybe your big computer secret. Okay, you can access, but the password is only with me, something like that. Okay, so the security should be with the password or maybe the key. Security should be like that. Finding password is, finding the key is difficult. Even the algorithm is public. This is the case for every application. The algorithm is public. Okay, so only you can just exclude the case for military applications. So they don't give the algorithms also public. It's proprietary only. So otherwise, you cannot say that, see, my algorithm, whatever I design, is secret, so you cannot break. No, somehow the other way the algorithm will come out. There will be some internal people, maybe they are resigning and going from that company. They'll obviously will keep this algorithm out. They'll tell this is the design, I know. Understood. But still, if the design is out, so this happened in literature many number of times. Okay, there was a stream cipher RC4. It was initially, it was used in network protocols. Okay, so it was for many years. It was secret proprietary, but later it came out. Somewhere in the website it is published. Okay, so the security should depend upon the password, the key, in other words, in cryptographic language. So that is the thing I want to tell you. Now we'll go into more understanding about authentication and what type of methods or functions we are using to provide this particular service. So if you have any doubt with respect to these services, you can ask me. I'm going to the next slide. Okay. So the hash functions are used for providing one of the functions used for providing integrity, message integrity is hash functions. Of course, hash functions can be used for providing entity authentication also, not completely, but you can use for providing entity authentication as a part. You can use one function, okay, for providing entity authentication, message integrity, and so on. Okay, but not message confidentiality. And the previous sections you have heard other symmetric or asymmetric ciphers are used for that. Okay, so this is one of the classical ciphers. Just I thought I'll show it to you. Okay, World War ciphers or whatever, World War I and II and so. Okay, something like a typewriter you have. Okay, some physical devices, electromechanical devices. Okay, which was used many years before. It was cracked, and some issues were found with these type of devices, and messages were read from the ciphertext. Okay, these were very old type of devices, and the technologies used inside also is very old. Just to get a feel, I'm just showing you here. So you can see that there is a message and there is a ciphertext on the other side. So, block ciphers and stream ciphers, keep this in mind. Only just I'll quickly go to the next slide. So whenever cryptography, somebody is talking about that, you will have block ciphers one part and stream ciphers another part. Okay. These are all coming into the category of symmetric ciphers, which was I was telling you in the World War I, II, 60s, 70s, before the advent of asymmetric key crypto system, which was introduced by Arvind. Right. Before that, only this type of algorithms were existing. So few ciphers I have put here. There are some standard ciphers. So stream ciphers, we call it as RC4, trivium, grain, or even secure ciphers, lightweight ciphers. Okay, which is existing in the internet with the code and everything. It is available in the internet. You can see AES, DES is obsolete. Percent, it's a name. Percent is a cipher's name actually. Okay, it's a lightweight cipher. Lightweight in the sense the cipher can be implemented in very power constrained, memory constrained devices. Okay, that type of devices are more, right, sensors and so on nowadays. So present is a lightweight cipher. Blowfish is a very old cipher, but simply to get a feel, I have put some ciphers here. So this session is about authentication, right? Data authentication, integrity, message integrity, and so on. So here this hash functions and some hash functions I have displayed here. You can see here. MD5 is a hash function. SHA-2 is a hash function, right? Some terminologies, maybe if you are listening for the first time, it looks odd, but it's okay. But these are some of the standard. I'll show you in the next slide also. MD5 and SHA-2, and SHA-2 is secure. Even today it is secure. People are using it in the sense you can find in many softwares, security softwares, okay, applications, and you can find in many being used in many network security protocols and so on. Okay, MAC functions. So this MAC function, MAC, is message authentication code. It's not that MAC related with your computer's physical address. Not that. It is message authentication code. IP and MAC, not that it is. Okay. So message authentication code is the terminology used for providing integrity to the message, data. Sorry, yeah, authentication to the data. Authentication to the data authentication I am talking about, right? Data authentication, like entity authentication. So this will provide that. So MAC, message authentication function. So just at least keep these terminologies in your mind whenever you come across this. At least you will recall that, okay, I have heard this somewhere here. It will be easy for you to quickly go through the whatever document you have. You will understand very quickly. Okay, so you can see here this hash function. There is an input, there is an output. You can see that on the top. So hash functions will obviously take an input of any size, 1. So I'll converge this discussion telling that hash functions will provide message integrity and data authentication also. That's the objective. So you can see the output of hash function. I'm calling it as not working. Yeah, not visible. However, the output I'll call it as hash sum or checksum. Okay, call it as checksum. I'll show it directly in one of the web pages, or you can call it as hash value. Okay, or you can call it as message digest. Okay, that means what is happening, you can see here the input to the same hash function in the yellow color, they are of different sizes. You can ask, sir, why are you giving different sizes? You can see there it is fox, then red fox runs across the ice, the red fox walks across the ice. Small difference, the second and third. But still, the first and second is in lengthwise, it's different. I can even put a 1 GB of data there, which acts as an input to the hash function. 1 GB or 2 GB does time. It will take some time for uh, processing and getting an output. But always you can see that the output is fixed. You can see that, right? Simple example hash function. The output is always fixed. How many letters you can find there? 1, 2, 3, so 8 letters. So each letter will take 4 bits. So 8 into 4, 32 bits, right? So the first output is 30. So why it's always nice we encode everything into bits and we discuss, because everything we are processing in bits, we are representing in bits, measuring in bits. So it will be always nice you encode anything into bits universally. So discuss. So I am saying here, even though symbols are there, the hash sum is, it is simply 32 bits, 32 bits, 32 bits. So whatever input is there, it is a fixed output. So I can conclude here, hash function is a process. It is a process, is a method where it takes any input data of any size and any input, because I am only giving here text, but I can give video also that I am dictating here. Video, I can give audio data, I can give images, okay, but you have to suitably encode that, okay, and then process it. And I can give text like this of any size, and then always it gives you a fixed output. Here it is 32 bit. Now this is the case. Now there is one more thing I would like to say. So I put this particular one here because I just want to show you. You've heard about SRTP protocol. This is RTP protocol extended to SRTP, where the S implies secure there. This is one of the protocols where we use this protocol for as a transmitting messages over network. Okay, so live data communication, like VoIP, Skype, VoIP, and so on. So just I want to show you here that you can see this payload. You can see the payload here on the top, that is RTP, a payload, RTP header, UDP header, IP header, and so on. Okay, but where the message is actually there, it is actually RTP payload. There is the message. Remaining all is simply the metadata related with the message. Now, actually, I need to encrypt this, right? I need to encrypt this RTP payload. So here there is no encryption. Nothing is there. Simply is put like this. There is RTP payload. You transmit this particular packet, this one, and this will give some information about this, and then you get the message on the other side. But yes, RTP is simply the secure. S for secure. The security is added to that, like authentication, message confidentiality, integrity, and everything is put inside this. This is one example of that, where all these services are provided here. To show you that, just I put here. Okay, so I'll show you another service also. So another application also where these services are used. Now you can see the same protocol has been changed here, where I am encrypting the payload portion. Okay, and I am authenticating data authentication, not entity authentication. The data what I am collecting here is RTP header, some information about this data, RTP header, and the payload also I am taking. Payload can be of any size, maybe in bytes or whatever. Okay, so the RTP header and the payload together is being authenticated. That's a different process, keep in mind. That means if it is authenticated, I'll get some AUTH, some data called auth. Okay, so this auth will be containing some information about this and this combinedly. Now when this is transmitted on the other side, okay, now he will take this, okay, or he will try to construct the same thing using this RTP header and RTP payload and encrypted data. So from this data, he will try to construct the same thing. So there is some secret, because when you're doing encryption, there is a password or keys required. So recipient also will do the same process, and he should get the same auth AUTH. So this will be used for authenticate. If it is verified, obviously nothing has been changed inside this. Okay, but this can be read by anyone. It's only authenticated. You can see this line here, only this portion is, this payload is only encrypted, but this is put into authentication process. Why? Because Sometimes the header has some details which not be changed. Some people will also put this data also into the authentication process because they don't want somebody to change the IP address or something like that. Okay, but they can read. Anybody can read. Any router can read the IP address because the routers are sending the data from one place to another place. The router should read the data and see, oh, this is the IP address. So you're going there. It will route. So it should read. You cannot encrypt those sort of information, right? Destination address and so and so. So, but an authentication has to be. So if somebody can change it, so that should not happen. Immediately somebody changes the IP address or some related metadata, on the other side, somebody should understand, right? As they have changed it, it's wrong, and so on. I should not change the source address. The recipient will get a lot of issues, right? So obviously that has to be authenticated. So in the whole process, this whole data, some part of the data should be only authenticated. Some can be encrypted because whichever is to be kept private should be encrypted. Remaining all simply authentication. This is the whole thing happening in most of the security protocols. So we are discussing about the hash function. Okay. So I'll go to the next slide. Yeah, you can ask. These are designed and available publicly. We can choose our own hash functions, which are standard hash functions, which I'll display and show it to you. Or we can design our own hash functions if we know the techniques of design. But always not suggested if you are not a professional to design. We had our own designs, but not recommended if you are not a professional in making the or designing that particular hash function. Because some standard hash functions are there. One of them I told you, SHA-2. Okay, same like DES and AES, there was a competition requesting for proposals all over the world, and then round 1, round 2, round 3, and SHA-2 is one of the algorithm. That name was given SHA-2. Its actual name was not that. Okay, some others design idea was finally published as a standard. It's secure hash algorithm. Okay, 2 means it's a version 2. There was 1 also, but now it's obsolete. Many agencies, companies, institutions told that no, we are not doing. Please, nobody use SHA-1 in any of your softwares. Okay, or maybe any of your protocols and so on, because of some issues with that, some security issues and so on. So, but SHA-2 is secure. Even today, it is secure. People can use it. Now, the other thing is, again, NIST, National Institute of Standard and Technology, they again conducted a competition very recently. Recently, in 2015, it was completed. Again, third version of SHA hash algorithm. Again, competition was conducted. Competition round 1, round 2, round 3, and the final candidate was called as SHA-3. SHA-3. Okay. So, but SHA-2 is still secure. Okay, SHA-2 has some variants inside that. Now, see here, I told you this is the hash function, right? I told you this is 32-bit. Whatever input you give, it is 32-bit. That is interesting. Now, if for SHA-2, what will be the output of this? That is the question. Whatever input you give, what is output here in bits? I'll tell you for SHA-0, there is SHA-0 also, the first version, which did not exist for more time. Immediately SHA-1 came because of some issues with the design. Okay, so SHA-1 is SHA-0 and SHA-1, the output size is 160 bits, 160 bits. So whatever you give here, whether 1 GB of data, you will get 160 bits. Understood what I'm saying? And this is only a one-way function. If it is a cryptographically strong hash algorithm, this algorithm has a special property called, you can only find like this. You give an input, you got this. Now you ask the output, who is your input? You will say, I do not know. Understood? Now you take this function, force it back. It will not give you this output. Understood what I'm saying? And now you can ask, so the domain of this is like a function, right? So many inputs, but the output is only countable, right? You are fixing 32-bit means how many 32 bits will be there? So 2 raised 32. But how many inputs are there? Then you told, sir, not 2 raised 32, it is infinite. You can so many. Any video, any audio of any size and so on. So many, right? So obviously you can say that when you invert this, when I'm going on doing this process, there will be more than one input having the same output. Because input is so many, output is less. How do the inputs share the output? They have to share some common outputs, right? Only 2 raised 32, 32 bits. Understand what I'm saying? So that is obvious. But the problem is, now finding when you invert this actually, there are hundreds and lakhs of inputs which will give you this. Those inputs when you put here, you can find the same output. But the problem is, it's not that you cannot find, you cannot invert. It's not like that. It's computationally difficult. That word is very important. It's computationally difficult to invert and find at least one fellow. But among them, one is the correct one, which I used. Fox is the correct answer. But there will be so many inputs which has no meaning at all. Dollar $X, Y, Z, something like that. When you that also you put as an input, you'll get the same 32 bit. Same 32 bit here. Like Fox, what you want. But you do not know. Finding at least one of them in the hundreds and thousands, it will take so much, maybe 10 years or maybe it depends upon your computing facility. So it's computationally difficult to find. By the time you find, people will change the hash function, they'll change the application, they change the data. By the time the data is not required for you, right? Understood what I'm saying? You want to decrypt and read some message, after 10 years you're getting, who wants that? Understood what I'm saying? You can ask me. Yeah, so here there is nothing like a confidentiality or something, because encryption algorithm is only for taking a data, 1 GB of data, you process, it's also a function, right? Something like this. You write here encryption function, that's it, nothing different. But it takes a 1 GB of data, particularly symmetric ciphers I'm talking about, okay? And you'll get the same size data. 1 GB, it should give you 1 GB, it should not compress or expand. Let us assume initially like that, okay? So 1 GB encrypted, so maybe 1 GB of data, you'll get here 1 GB of data. The difference is this fellow has some meaning for us, okay, English or whatever language, but this does not have any meaning. It looks like random data, some scribble, okay? And from this, reading this for so much time, you will not be able to understand what is this. And why does it happen? Because of the function you are using here and the type of key, the key you are putting here, right? The key is also required. Now you can do the reverse. Now if you want this one, you want to get this one from this. That means in the case of encryption, the ciphertext 1 GB, you give as an input, reverse it and get back. Reverse should happen there. Otherwise you will not be able to read. The recipient will not be able to read. But when you do the reverse only will happen when that secret is known to you, encryption function. But here we don't want the reverse. That is the way I'm constructing the concept of hash functions. Understand what I'm saying? Nobody should be able to reverse. Why? Because, so this is something like this output, I'm calling it as checksum, or it is a tag. I'm putting a unique tag. It should be for every message a unique thing I'm putting. Now, for example, you have an image you want to transmit to your friend. Let us assume an image of large size. You encrypt it using encryption algorithm. What do you get on the other side? Again, of the same size data you get, which has no meaning. That image has no meaning at all. Okay. Now, keep it aside, that is encrypted image. Understood? Now, what I'm doing is, the same message, same image, I'm sending to the hash function. Same image, which I encrypted. What will happen? It will give me 32 bit. It will not give me again another same size of data. It will give me a 32. So, this 32 bit, now you give another image, it will not give the same 32 bit. Okay, it's difficult to find another image which will give the same previous 32. It will take some time for you to find. That is my security here. Okay, so this 32 I will consider it as the identity or the tag corresponding to the image. So when an image is given, I got a checksum here, and that I call it as the identity of the image. Whenever the image changes, its output changes here. So for every image, there is a unique 32 bit. So 32 is very small. Generally, we use 160 bits or 256 bits. Okay, so that it will not repeat quickly. 32 will repeat. 2 raised 32 will, So 2 raised 32 images, if you use one image, 2 images will surely collide. 2 images will go to same output here. So if it is, I'm taking 160 bit as an output for the hash function, at least to collide, you have to do 2 raised to 160 times. You have to do this process, right? So that's not possible, feasible or not feasible, whatever. So, so that's why I call every data that I encrypt a message, I can create an identity for that, or maybe a tag for that. In simple words, tag. So take the message, encrypt it, generate a tag for this, and attach to this message and send. Is that fine? Now this tag is unique. This combination, this message and tag is unique. This combination is unique. If you change the tag, then this message tag will not tell you. tally. Once it reaches to you, what do you do? How do you find that this this is the exact tag of the particular message? How do you know? When you send the image, encrypted image, which has no meaning, and the tag to me, what I'll do, I'll take the encrypted image, I'll decrypt it, I'll get the original image. Understood? Then when I get the original image, I'll again apply this hash. Okay? What I get? I get the tag, the same tag, and the received tag, and the tag I generated, I'll verify whether they are same or not. If they are same, then verified. That means while the encrypted image is during the transit of the encrypted image, nobody modified it. That's the thing. If somebody modified the encrypted image or they modified the tag, it will not tally here. Understood what I'm saying? Is it right? Two things being transmitted to me. One is the encrypted image and the tag. If one of them being modified, let us assume encrypted image is modified 1 bit. When you decrypt it, you will not get the original image. If you don't get the original image, again you hash it, you will not get the actual tag. Understood? Tag will not verify. Is it clear what I'm saying? So this is the way, like you go to supermarkets, no? Every product has a unique tag attached with that. The product is not identified based upon its what the product details. No. Okay, not only product details, some tag is required. The tag is of course generated from the product details only. Take all the product details, compress it and put a small whatever information like tag like thing. Okay, based upon that you will identify that. Of course tags will repeat, but the number of products there, okay, is not so large, or maybe finding two different products having the same tag, it will take 1 day or 2 days for you. By the time supermarket is closed and you're out. Understood what I'm saying? So it's computationally difficult. Of course, tags will repeat for the products. Understood what I'm saying? So something like this. Just I took an example so that I can make you understand. Okay. Now, very important and nice example of hash function. So this is open source. See, somebody want to. Sir, we are listening so much of theory, but can you suggest, or we have to go and write a program for using software which encrypts our data. Can I get a feel of encrypting a data using AES or some other symmetric ciphers? So this is an example for you. Okay, so you can use. Very importantly, somebody says that, so this is a software which will encrypt your data. Immediately don't agree with that, or don't accept, or don't take it to be granted, because so if it is an open source, then it's fine. This is an open source software. We do not know what is inside that. Really, that algorithm is existing or not, you do not know. I'm scripting it. I'm giving you the exe. How do you know that really A is inside? Understood what I'm saying? Or I'm using only 32-bit key inside. Wrong implementation. Intentionally, I'm putting a wrong thing inside. A 32-bit key only I'm putting inside. So obviously, I can able to easily read your data because 32-bit I can crack. Okay. So you have to use the softwares, whether encryption or authentication, whatever softwares, you have to get it from some trusted third parties. Trusted, right? Now, the best thing is always this open source, because you will have the whole code with you. You can verify, you can go inside and verify everything. Okay, maybe you can tweak accordingly and use it. Understand what I'm saying? Some updates also you will get. This is VeraCrypt open source disk file encryption. Very nice and interesting, very good interface it has. Okay, so I'll show you one more screenshot here. I'm using it for many years. Okay, previously it was called TrueCrypt, and later it is renamed it as VeraCrypt. Maybe a different team is updating this. See, like this it comes. Very nice interface. That means what will happen, it's something that technology here is something like on-the-fly encryption happening. On-the-fly encryption. You know what is on-the-fly encryption? When you have a ciphertext file, you click on that, it will decrypt, of course, it will decrypt, but the decrypted thing will be in the RAM. Okay, it will be in the RAM. The key also will be inside the RAM. And the decrypted whole ciphertext, which you are seeing as a plain text, it will be opened in a virtual drive. You can create a drive. You can open it as a drive. It will ask like this. What is the drive you want? It will display all the drives which is not in your laptop. So this is my laptop, so it has no E, J, K, and so on. It has some C, so it did not display. I can take P, click on that, and I'll say mount. And obviously, you go to that my computers, you can see that P drive virtually, it's not actually the pre-drive system drive, it's virtually open. Now, all files decrypted, whatever files you have put, right, that will be inside the P drive. Same like drive you can use, like pen drive you connect, there is a, it looks like a drive, right, externally connected thing. Similarly, it looks like. Understood what I'm saying? Very nice interface it has. Even if you put that one encrypted file in a OneDrive or somewhere, Google Drive or somewhere, when you open the Google Drive and click it, understood? That's a ciphertext you're clicking. Open with, it'll ask you password, type the password. If you lost the password, it's gone. Nobody can get you back the data. This encryption, it's not a joke because you are using very standard encryption techniques inside. You are given the opportunity to choose the encryption algorithm. AES example. You can increase the security also by choosing the number of rounds, etc. Some options are available. So, key is gone, Understood? It's gone, that's it. You can forget about that particular data. Is that clear what I'm saying? So, it is something like, quickly I'll show this because there is a very important thing to be shown in the next slide. So maybe just a minute. So I have a file here. Yeah, this one. So if I create, you're not able to see. Maybe I can pull like this, right? Oh, okay. There is no extension. There is no icon. It's a ciphertext. HLLO. Okay. Now you can decide what is happening here is you are creating a container. They call it as encrypted container. You can decide 10 GB encrypted container or 2 GB or 5 MB. You can decide. Suppose 2 GB of encrypted container I am creating. What will happen? There is no data inside that. It will create it. It will push all random data inside that and make it a 2 GB of container. That means when you create that container, nothing is inside that. Random data only. But why? Because it will occupy 2 GB of your space. You're gone. Your C drive or D drive, wherever you're storing, 2 GB of space is gone because that file is 2 GB. But none of your files are inside. Okay. But when you put 10 MB of file inside the container, from the 2 GB, some random data of 2 MB or 2 MB or 5 MB, whatever it is, that is deleted and this file will occupy there. But still, when a person who is having access to the laptop, he sees that file, you only have 5 MB of Word file inside that. But when you see this file, this is actually whatever name I gave, this is a 10 GB file, example, 10 GB or 2 GB. It's a big file, but this file inside it has only 5 MB file, my actual file. I'll show you that now. So let me quickly open that. So, right click, maybe there is open with, right? Open with. Okay. Oh, I'm sorry. Oh, this one, right? So, another important topic I need to tell regarding hash functions. So quickly we'll go. So you can see this directory you install. Open with. Now that's a junk-like file. Hello. Nobody can get any information from that. Give to anybody. It's a ciphertext. It says ciphertext. Okay. So see, I'm going to open with this. Okay. Oh, it's already opened in E drive. Maybe I have opened it. So I can dismount and again open. So I have to think about the password. I remember the password. Otherwise, I cannot open and show it to you. So before I go and try whether the password is correct or not, I have chosen E, right? Let me say, oh, E is here. E has come. It's not the system drive, it's a virtual drive. E. Is that okay? What I'm saying is clear, right? So I opened in E. That file has come. Now click on this. See here. This is the file. Now this file is, see, this is completely maybe a 2 GB of container. This is a container created randomly, inside randomly filled, but it has only 18 KB file. So that means maximum up to 2 GB data I can fill. Then the random thing will go out and will fill with the data activated. So how much data you put, still it is 2 GB. So for an external person seeing that, he cannot understand how much data is inside. He will still feel it is 2 GB or 10 GB or whatever. So you have to choose the type of file also. NTFS or FAT or whatever. So the file system you have to choose. Based upon that, you can have bigger containers. It's easy, you can try by yourself so that you can get a feel of encrypting your message in real time. Okay, encrypt and put in OneDrive or wherever. And when you click that particular file from OneDrive or maybe Google Drive also, right click, open, you know what will happen? This file is coming and then getting decrypted in RAM, not in the Google Drive, it is getting decrypted. Still, somebody opens into your Google Drive and see it is only the ciphertext available there. Okay, the plain text is only in the RAM. That means what happens if this computer is switched off? If I switch off and restart, my E drive is vanished. That's what I'm saying. Again, I have to give the password and open it. So, so I think this should be enough. I'll dismount. Okay, dismounted. It's gone. You can see here it is. Very nice options are there. You can also the whole disk you can encrypt. Only the problem is while booting you have to give the password. Okay, so but very careful. Once you forgot the password, it's gone. Understood? You can reinstall the system. Again, use the system. Laptop is okay, but the data is gone. Complete data is gone. So be careful while you do this. Okay, instead of passwords, you can also choose the files here. Some image, your photo or image file or a text file, that can be a password. It will take a file as a password, but the same file without any modification, you have to give it, otherwise it's gone. Okay, so many options, but nice to understand how the encryption works and choosing the encryptions and so on. Okay, so you can try. There are so much of step-by-step process given to you in the internet how to use this. This is not only the one open source software, there are many, but this is nice and easy and very nice interface it has. That's why I explained this one to you. Okay, so see here I am just taking mount. It is asking me a password. So it is asking you that to use key files. Do you have any file or you are using password or both? So I'm going to use password only. So I'll type here. I think it is hello, the password. I did not change anything. If it is true, it will come. Otherwise, it will not come. It takes some time based upon your algorithm you have chosen. I used AES. Actually, AES has some number of rounds, 12 rounds. You can increase the round to increase the security. But the problem is, it will take some time to get back the whole container. It has to open, right? As a virtual drive I. If the password is wrong, after last it will say that wrong. Something gone wrong. The password is wrong. Oh, it opened luckily. HLO only. The file name is also hello, right? So it opened. Now it will be as iDrive. So it is here iDrive, right? The same file you can see here. And really, if you use the very nice standard ciphers, AES or something like that, trust you cannot. Nobody give this file to anybody. Hello, the ciphertext. Nobody can decrypt it. Very difficult. Understood? And that file is gone. If you forget password, it's gone. You cannot go to any technical guy and ask him to decrypt. Not possible. Okay, because standard ciphers are being used. So I thought I'll show that exactly how to work, but lack of time, I'll go into the slides. Yes, this one here. Yeah. And this is about getting a feel of open source software for encrypting your data. Okay, video data, whatever. Please ask. A little bit loud. Dynamical. That option we have to check. There are many options in this software. Like even there are some options like you can set a password. The container will have two parts, one hidden part and the main part. Okay, when somebody is forcing you to ask you the password, you can give the password one part where the very secret information is not there. The other, because nobody knows that two passwords are there for the same. So many options are there, but dynamically changing or increasing the volume, I did not use that, but we have to check whether that is available. So I think so, no, because after I did the whole thing, but still you can check it out. Okay, there are many options. When somebody is asking and forcing, please come on, tell the password. You will type the password, but the content is word files and simple. But there is another password when you give it, will open the other part of the container. So that has something else. So that type of applications, I don't know. Maybe it will be useful for you or may not be, but I think so. That is also available. You can read that whole thing and just see. Okay. So yeah, the other one, what I want to tell you here is a very nice application of understanding all the crypto what we discussed from the morning. One is asymmetric key crypto system, and Saurabh regarding the block ciphers and stream ciphers, symmetric key crypto system, that is, okay. Authentication, message integrity, entity authentication or data authentication, okay. All these things together are used in this single network protocol. It is previously SSL, secure sockets layer protocol, okay. Uh, Presently it is TLS, updated version TLS, okay, transport layer security protocol. This protocol is a protocol that connects a client and a server. Okay, you are trying to connect to sba.com. Your browser, you are just typing in the browser, right, sba.com. Obviously, it gets connected to the server. So there is a communication happening between the server on the other side and the client with the help of your browser. You are the client. Your laptop is the client, and your browser as an application is doing all the things for you. It is trying to communicate. So there is a handshake happening. When it takes some little time, right? 1 second or maybe less than 1 second. In between, what it is doing is this browser is asking, okay, fine. What is your identity? It is asking the servers. Understood what I am saying? So as I told, digital signatures, no? Immediately the SBA server or Flipkart or whatever, Amazon or whatever services, it is immediately, yes, I am SBA.com. What is the guarantee? This is very small starting handshake protocol. We are handshake, no? Starting, we are trying to communicate. We give a handshake. Tell me about your identity. Okay. Then for client side, generally the authentication may not be required. Only credentials we give and get inside. Okay. So it is an optional only. Client side authentication maybe we can or we may not use. Okay. But server side is required to whom we are connecting, whether it is really SBI or somebody else. We do not know. So I took an example, this SBI and Flipkart, okay, to make you understand. So, so there, this handshake, I'll ask, please show your identity. Then the server says that yes, I am so and so. How? What is that it is showing? That is called digital certificate. Okay, digital certificate, where the private key, it will not be there, but public key of that particular server will be existing in this. So there are two keys, private and public. Private will be with the secretly with the server, but public key will be here, and some other information about the company or institution will also be here. And also who issued this certificate, everything will be inside this. The moment the browser gets this, the browser verifies this. You do not know, knowingly or unknowingly using it. It's a fraction of seconds it is happening based upon your browser, updated browser and so on. So browser is already saving so many certificates in the hierarchical order. So many certificates up to the CA, root CA and so on. So many certifying authorities, certificates are kept here. The moment the SBA server is sending the certificate, it will verify from the list of servers it has. Who signed it? Is the certificate signed by one of the certifying authorities who is with me in the browser? Yes, it is. We verified. It was verified. Then immediately, yes, we understood you are SBA.com. Now let's communicate. Understood what I'm saying? Understood, right? So everything is inside this protocol. So if you are able to understand this SSL, previously called SSL 3.0 version, it is attacked. Okay, now there are some issues with SSL 3.0. Updated version TLS 1.2, 1.3 and so on. So that particular protocol you understand, the whole thing is understood by you. You understood the network protocol. Okay, you understood all sort of crypto services. Every crypto service is inside the single protocol. Very easily understandable. Nice also for you to learn this. Okay, you can try for understanding it, implementing it. Okay, so and so on. Just I put here so that you will understand something like this. So this one, the message integrity, two things I want to tell you. It is modification detection code, and there is something called, before I go into this, I'll show you, lack of time, so I'll show you this one, message authentication code that I already displayed, MAC, message authentication code, MDC, modification detection code. What is the difference is, message authentication code or modification detection code of a message, both has message, right? Of a message, they are simply a piece of data, 120 bit, 100 bit, 160 bit, whatever. It's actually the output of the hash function, you can say in simple words. But what is the difference is, one has authentication, the word, another has nothing, right? The first one is simply modification detection code. It's a code or a tag that is attached to the message. It only detects if there is something modified, nothing else. I'll show that practically now. We have some half an hour. Okay, but the authentication, message authentication code, it not only detects, it also tells that from where the message has come. There is an authentication. That means some secret information about that particular user also should be inside this, like key. Understood what I'm saying? So I'll show you the MDC, modification detection code, with the help of hash function. So hash function can be used for providing MDC. Of course, it can be used for providing MAC also, but I'll show you how this modification detection code can be generated using hash function, and that can be used for message integrity. Okay, so we'll see that. So some of the hash functions. So we'll do one thing. I'll show you first of all how to generate output of a hash. Just give this one, no, what in the previous slide I showed you. Hash function, it takes any message, gives a fixed output. That I am going to show you with the help of an application in your Windows. Okay, it is Windows PowerShell. I'll use that small command. I'll take any file in the system, in this laptop, and generate the hash tag or checksum. And I'll also go to a website. There are some websites where, suppose for example, a website which gives you a software which is open source. Let us assume like that. So if I'm trying to give you a software through my website, I should also tell you that, see, this is the software only provided in this website. You will not get anywhere. Don't get it from anywhere else, right? I should tell that also. So what I'll do is this example VLC player or anything else like Ubuntu or whatever. Let's take Ubuntu. Downloading is difficult. I'll take VLC player, some 32 MB. So when you're going to download the VLC player, it's an open source. Then what I'll do is I will find the hash of this particular software, hash of maybe SHA-2, okay, or any other algorithm, it doesn't matter, MD5 or whatever. So SHA-2 of this VLC player is equal to, the output of SHA-2 is 256 bit, one particular version, okay. So immediately I'll get a 256 bits corresponding to this VLC player, okay. Then I will display that 256 bit in the website below. That's what I'm saying, guys. So there is VLC player is there. It's a SHA-2 of VLC player software's output also I put here. It's a 256 bit. I'll put in the hexadecimal format because 256 bit means so huge, right? It runs so much big. Hexadecimal means only 4 bits becomes one character. So 256 by 4, that many characters are enough. That's why people use hexadecimal characters. Easy representation. Okay. Now anybody is going to download, what they do? Or maybe she is giving me the VLC player software. So please use this. Who knows? Sometimes that particular software is maliciously infected by something else. Maybe 1 KB of something is attached with this software, which is 32 bit. Okay, when you see the weight, the size of that, there is no much difference. But some script is added to that. We do not know, maliciously or whatever. Then I should know whether this software is the genuine one downloaded from that or maybe attached something else. What I will do is I will find the hash of whatever software she gave with SHA-2 only. I get some 156 bit. I'll go to the website and download that and see the hash of that. Hash is already, they published it, right? Right? I'll see both of them. They are different. Version wise also they are same. If they are different versions, I agree. Okay, the content will be different and obviously the SHA output will be different. Sorry, the hash output will be different. Okay, understand what I'm saying? She told that it is the latest version. Please download. Then obviously latest version is in the website. And they also put the checksum out publicly with the SHA-2. I should get the same checksum, right? It is not modified. Even a bit should not be modified. Understand what I'm saying? So I will just show you. It is PowerShell. Just search PowerShell in Windows. Get this. Is that okay? So you are able to see this, or you want me to magnify it? Magnify. Is this okay? This is fine, right? This is fine. So it's not required to go and write this B column and so on. You can execute from there itself. Okay. So I need some software. So what I'll do is, so so I'll take. So the command is simply get file hash. It's not case sensitive. You can use anything. File hash. Okay, but which file I should take? So I'll do one thing. Again I cannot. I have to write the path here. I can put in quotes. Write the path. That's it. Get hash, and that path is enough. No need to tell the hash function also, because by default it takes SHA, secure hash algorithm 2, version 2. That means there are so many outputs it gives. So in 4 types of SHA-2 is there. I'll take SHA-256. That means 256 output will come. Understood what I'm saying? Done? SHA-256, 256 bit output. Okay. So that is the default. If you want a specific hash algorithm, then you have to type dash algorithm and algorithm. What algorithm? SHA-2 or SHA-3 or whatever. Okay. So we'll see here. Instead of that, what I'll do is, let me see what are inside this. Okay. This I have listed all the files and folders inside D. Now what I'll do is, again I will change the directory to maybe PhD. You can see there, right? PhD. You are not able to see that. PhD there. So I'm writing here PH. I think here it is case sensitive. Okay, now I'm in PhD. I list it. What I'm going to do, I'm trying to hash using a hash algorithm. You can choose any hash algorithm of your choice. Standard hash algorithms are available in the Windows. Okay, you have to update the Windows always. Standard hash algorithm already implemented in Windows. You can use that through PowerShell or maybe any other command prompt. So what I'm going to do, I have listed. Now I'll do get easy for me to read and type. No? See, I can see the files, only 2 files inside. So get file hash. Okay, you can type directly the file name. No quotes are required, but since there is a space, no, Shivanand underscore, so space DC. That's why the space is a problem. It will not detect. So put in quotes. It will be like a single entity. So it is SHI VANAMD, case sensitive. Okay, otherwise error will come. Close it. See this. Now this is actually, you can see 256 bit by 4. How much? 64. 256 bit by 4. Each 4 bit. How many 4 bits are there in 256 bit? 64. So 64 hexadecimal characters are displayed here. This is my hash. Okay. Now what I will do is, what you can do is, you can change the extension of this file. See, this hashing is happening only because the hashing is done hash off. This is the hash. Similarly, I showed you 32 bit. No, that is what is this. But if you rename this one, you change the extension to .pdf. What will happen? You have tried anytime? Take a Word file and change the extension .pdf. What will happen? The icon will change. It will give a warning and you will accept it. The icon will change. You will not. It is not readable. Understood? But still the file exists there, right? In the PDF symbol and so on. Now you take that one and do the hash. You'll get the same thing. It will not change. So that means it is hashing the contents of this file. It is not taking the name of the file, the extension of the file. No, only the content. So I am only identifying the document based on its content. Okay. Understood what I am saying? Is that clear? Or for example, if I have some problem and I'm challenging you to solve it, you will ask me, do you know first of all? Then what I'll do is I will solve it, but I cannot show it to you because you have to solve it. Then tomorrow you come, see, then third party, I don't want anybody else. Okay, something like that. So what should I do? I'll take this solution. In a single letter, I should not change because today only I solved it. No? Before she is sitting there, I am solving here. I'll take the hash of this and give the hash value to you. How much? 64 characters. Take it and go. Okay. And which hash function I am showing it to you. Tomorrow you will come and show that, so I am unable to solve it. Understood? Then what is the guarantee that today to next day I am showing the solution? What is the guarantee that this is the same solution you did it yesterday? And see the hash value. Take this solution, hashed it. Oh, it is the same hash value what you generated yesterday. That means you did not modify anything in that. Right? It is the same file. Content, rename or whatever you do. Understood? Message integrity. That's what is integrity. Message integrity. Content integrity, in other words. Okay, what I'm saying is understood, right? Now I'm not going to modify anything. You can try modifying. You can open this file. Keep in mind, you can open this file. It's a Word file. No? Open this. one letter you change, delete, or one letter you insert, you give a space, the document change, the content change. A bit change is content change. Now you find the hash. Now you find the hash. It's a different hash value. It's a different message digest. It's different, obviously. Understood what I'm saying? So that's a simple, very nice experiment that you can check it by yourself. You have Windows PowerShell. PowerShell. The command is very clearly existing here. Now you can. So one more thing I'll show you quickly. See, I'm going to change this to Shivanand PhD selection. Yeah. Then somebody is asking, sir, you do the next file. What is the guarantee that it will be a different hash? It's a different hash. Compare it. Okay. Now, if you want to download it from the internet, a particular file, this what's the file? It is this one. I'll just copy it now for you. Just show it quickly to you. So I'll go to VLC. Okay, it's a general website. Okay, so okay, because it's zoomed, very difficult for me. Now I'll download on this. Where is the checksum? This is the software. Okay, I'll download. When I download, somewhere below I should get the checksum. Got the checksum, right? It's downloading VLC something, and it's giving the checksum. Say display checksum. Yes, this is the checksum. Hexadecimal. It is, they told SHA-256. SHA-256. Okay, it's not SHA-384 or SHA-512. There is SHA-512 also. If you want larger checksum, you can take for higher security. Okay, the smaller and smaller the tag, easily it can be replaced, cracked, or collision can happen. So I'll copy this first of all. Let me copy. Now I'll go back to the Windows thing. Okay, I'm going to compare this because both are 256 bit. Both are 256. Is that okay? This one. This is 256. This is 256. What I got from the site for the VLC player. Let me assume that this is corresponding to VLC player. What she gave to me. Again, I cannot get another VLC. It's in the folder, but it will take some time. Okay. Now I'm going to compare this and that are same. I already copied, right? It's easy. You have some commands. I can give you that file also, which has commands. Now what you can do is you can do something like this, right? You store in a particular variable, okay, this particular hash, and you compare. That's easy to compare, right? See here how I'm going to do. It's you start with dollar, any variable you are declaring here. It is HAS hash 1 equal to, okay, or maybe I'll do like this to save time. Shivanand PhD selection. See, this will be computed. I want it to be stored in something called hash 1. Is that okay? That means get the file hash of that file. If you want a specific, if you want to say a specific algorithm, you will write dash capital A or small a, it doesn't matter. Algorithm, dash algorithm, SHA. It doesn't matter small or big. Okay, 256. No need to write this because default 256. If you want 512, I'll write here 512. That will be nice. But just to show that, I can specify the algorithm also. So it will take get to file hash using this particular algorithm, this file. Done. Okay. And then here I wrote equal to something, right? $hash1. It will store inside that. I'm going to store the same thing because it's a previous file, it will not change. So let us see any error. No, it has stored. No error. That means it is the same thing, guys. It is the same thing here. Whatever I got here, that will be stored inside now here, so that it will be easy. I cannot while comparing. It's not easy. 64 characters, character by character. I have to compare, right? That's what I'm saying. So now I will. I'm going to store hash 2. Actually, I should say get to file hash and find the hash of that software which I downloaded. Okay, I did not download any software now. I think it's automatically downloaded, but still what I'll do is directly I'll store inside this. I copied something, right? Put in quotations. Yeah, it's stored. See here. Directly instead of get file hash, I already know the hash, put in quotes, store it inside this. Okay. Now this equal to this or this not equal to this. So what is the output? Binary output will come. What is that? True or false, right? So let's see. It is dollar hash one dot equals. Easy to remember this. Okay, I also remember the same way. So one or two times you type, you will understand this. Okay, this is not only one way. You can also code or write your own script in PowerShell and use this. Okay, hash the first file dot equals this one. See, let's see if any error will come or not. It's false. If it is coming true, I am in trouble because that's not happened. So it's false. Both are different, right? You can see here already they are different by. You can see by our. You can write the scripts by your own way, and you can do this. Okay, this is already available in the internet. So this code I have used it for you so that I can show it to you. Now you can do so many experiments. Take files, change it, change its extension, change its name. Hash will not change. Change its content or attach an extra whatever thing with that. So some people intentionally will attach some malwares, right? It's changed, but we do not know. So you can check like this. So that's the important thing. So I skip to the next one because of lack of time. So what I can do is one important application I want to tell you about hash functions. You are using it. So this is fine, right? This is a modification detection code. No authentication. Understood? Why no authentication? The authentication is provided by the website itself. You are trusting the vlc.com. Directly you are going to the website, right? Now what authentication? You trust the website, then only you go and download. There is no requirement of any authentication. It's not data authentication. It's a modification detection code. You are going to the website, downloading it and checking whether it is modified or not. Okay, this is a nice example for modification detection code. Okay, message authentication code is different. I have to use some secret with that. That means, how do I generate? In simple words, I'll tell you instead of elaborating it. If you want to generate modification message authentication code, the difference is take the VLC player, take a secret password or key, concatenate, hash of this is equal to something. Now this is an authentication because data authentication because data means it's VLC player. Okay, data authentication because only I can do that, nobody else. Only I can do that. Why? Because only I know the key. So, or maybe my group knows the key. It's a symmetric key, so it's a data authentication code. But in this case, it's not required. Websites not required, right? So websites generally, system administrator or whoever, when they are loading this one, they can generate by themselves. So they write a code for generating the MDCs. That's the difference between MDC and MAC. People generally get confused. What is the difference? Okay. So what else? So these things I will avoid. So this is something like this Mac. It's a Mac. Okay. You can see from below there is a key going inside. Understood? So hash function can be used for generating MDCs. It can be used for generating Mac, provided you put a password or key there. And one more thing is a very important application of hash functions. So you are trying to understand the preliminaries of crypto, right? So obviously a very important application. Knowingly or unknowingly you are using it. Okay, you use these hash functions. Okay, for storing the passwords in your system. You know, anytime how your passwords are stored in your laptops, how the passwords are stored in the database of some servers like Flipkart or maybe Amazon. Okay, billions, maybe millions of users, their credentials, their email IDs, sometimes their phone numbers, their address, everything is stored somewhere, like in some database. Is that correct what I'm saying? Now, if that is the case, then passwords are very important credential. No? So, of course, it is in the database of a particular server, but some or the other day, a data breach may happen. It's happening every day. In 2003 also you can see many data breaches happening for some selected websites, right? Data breaches are happening. Obviously, this database or the control or maybe the copy of database goes into the wrong hands. The hackers, where they sell it to cyber criminals, right? This is happening. What will happen if a particular website in which you are registered as a member, your username, password, everything is there, and it is going in the whole password database file is going into the wrong hands? What will happen? What will you do? You sometimes will not know that. That is a very important thing, unless when it comes into the news, you'll know. But so if the plain text is stored, so this password is stored in a plain text format, it's gone. So there is a table, let us assume like there is a table where the password is stored in a plain text format. Okay, something like this. You're able to see this? Username, so many usernames, so many passwords. This is gone. Hack, some issue with the websites, right? It can happen, right? So many sort of attacks are there. Maybe some issues with the application, web applications. Obviously, you can get into the databases. This happened, and this is true. Nobody is going to keep like this any file, password file. Even your laptops will not put passwords like this. You can have more than one user, no? Here, more than one password. Understood what I'm saying? It's not possible. It's okay, it's possible. But what we are going to do is, instead of doing like this, the better thing to do is take this and this password. Don't store the password. Store the hash of the password inside. Hash this and put the hashed value here. How many? 64 characters. No, if it is SHA-256. Understood? If it is SHA-1, 160 bits, why 4? Then that many characters. So take a hash function and hash it, store it here. Now what will happen, you know? Go to your laptop, immediately type the username Bob, type your password. This is the default password, no? Many people don't change their passwords also. Okay, password 1, 2, 3 and so on. So social engineering. So password, you type password, immediately it goes, this password will be, the operating system, what it will does is, it will find the hash of this password, because the password is not stored in the system. Then how can it give you authenticate? It will authenticate you. So what it will do is, it will find the hash of this, and the hash of this is always unique if you don't change this. Then it will compare with the hashed value, which is already stored in the table. So that table I'll show you. It is in the next slide. This is one. All the passwords previously I showed, no, the Bob's hash value is like this. Now hash it. Now see, compare it. The comparison verified, you are giving access. You are being given access. Laptops only 4 users, 3 users, 5 users. Millions of users for web servers, right? Millions of users. It's gone, it's gone. Everything is gone. Now the problem is when data breaches happen, now you're safe, right? Oh, my password is not in plain text format. Nobody will understand my passwords. Even somebody will attack the server and get back this password file. My username is gone. It's in plain text. My phone numbers may go, but my password is not gone. If password is not gone, he cannot log in to my account. But the problem is, still there is a problem. A very good hacker, what he can do is, he can pre-compute a table. Okay, a table he can pre-compute like this. What he will do is, he will, so much of computational power is required. Okay, let us assume that he is a computationally strong adversary, having enough space and so on. Then he will create millions of usernames, millions of common passwords, because people know what type of passwords they use, right? Password 1, 2, 3, that is this millions and billions I'll create, and I'll take standard hash functions and hash it, and create a very big table. The table of data, maybe 20 GB or 50 GB is available in the internet. 50 GB, 60 GB, some people will sell it for you also. Okay, you can buy it also. Now that only you should have a space, some computational power, offline computational power for creating this. Understood? Now what will happen? That is with you, common passwords are hashed. Now whenever you get a password file like this corresponding to a website after hacking, now what I'll do is, I will just do a table lookup. At least one hashed value is matching with any of the hashed value in my created big table. Understood what I'm saying? If there is a match, then Bob's password is password. Okay, but corresponding to some other name, I got the same hash value. That means in my table, it's not password, it's not corresponding to password, it's something else, XYZ123. Its hash value corresponding to the hash function is this. And what I'll do, I use that password to log in. It will give access, because when it is hashing, it is equal to the same thing, right guys? When I give that XYZ123 as a password, which also have the same hash value, this one, It will verify it is verified and it will give login access. No, so this attack is called it's a rainbow table attack. So this table is called rainbow table. Okay, you will get the rainbow tables already offline created tables. Okay, just it's a lookup table, but you want more and more. Again, there is see whenever there is some issue, again there is a solution for that. People find solution, right? Cybersecurity experts will find a solution. Okay, the solution is something called this is a password database using hash functions. Okay, see the hash functions. I will stop maybe 1 or 2 minutes. So using rainbow tables, see here. So what is the solution for that is, see here the solution is salt. So the name salt and pepper is there. Salt in the name of salt and pepper in cryptography. Salt means take the password. Password is let me in. This is the password. Put some salt to it. Okay, salt in the sense of random value. That's the meaning. Okay, it's a funny thing. Put some salt to it before you hash. So generate some random data, attach it, and then hash it. Very difficult now creating a rainbow table. Now it's not only that you take commonly known passwords to hash, you should also generate some random data also to that. Now creating such a big rainbow table is completely difficult. It consumes lot of amount of the attacker's time. Understand what I'm saying? So this way I create. Now in the password table, what are there? This salt is also stored in the password table as a plain text, and its hashed value. This fellow also will be there. So if you want, I'll show in the last slide. This one. Oh, this one. Yeah. So that's it. This one. This two. Okay. These two are not equal. I'm putting an extra salt. This one and the salt together are stored. Okay. So now when I log in, just as a user, I should only give this. I don't need to keep in mind salt. I'll only give let me in. When I give, it goes in. OS will take this particular salt, which is attached with my username, takes that salt with the password, whatever I type, it will attach, find the hash, it should be this, if not wrong. So only you remember this password, nothing else. So this will increase the computational complexity of the hacker because he creates a big table, no? Then it's very, very difficult. Not only the common passwords, he also should generate the random data like the salt. So a little bit more you can increase by something called pepper. Okay. So now we are going to add a little bit more to the data. It is password is the last slide. Okay, I'll stop. Password, some salt, random data. It's unique for the user. Keep in mind, the salt is unique for me. Another user, another password, the salt is for him unique. It will not change. Okay. Then it is stored also in the table. Then take a pepper also attach at the last. So password, salt, and pepper concatenate and hash it. And this pepper is secret value. It's like a key. Okay. A little bit more to increase the complexity. They are putting the secret value, and this important point is where to keep the secret value. It will not be in the password database. The cyber hackers will not get that. It should be stored somewhere, maybe in some web application code, maybe even it's not secure. You have to keep somewhere else. Okay, in some other database or wherever, which can be accessed automatically. So there are some means or ways of storing. The pepper is not in the password table, but salt is there. Salt is the random data. So just that's it. I'll stop here because of lack of time. So, however, just I want to tell you that applications of hash functions are a lot wide, where it is used for providing message integrity, not only message integrity, data authenticity also. Okay, for both we are using hash functions, and the conclusion is not only hash function, there are other methods of generating, providing the service message integrity, not only hash functions. So it takes some time for understanding that. Okay, this is enough. So that's about hash functions and authentication. I'll stop here. If you have any doubts, I'll take. Salt is a random data that is generated of some fixed size. It could be 100 bits or maybe 120 bits or 128 bits or something like that. So when you add this password with the salt and do the hashing, okay, so you get some output, right? That is the same line, okay. But this is important while somebody is trying to create some rainbow tables, okay, for attacking, because rainbow tables contains all usual commonly used passwords, millions in number, will generate and find its corresponding uh, hashed values. But now there is another challenge for him because the particular website or server is using an extra random value also with the password and hashing. Now to create the rainbow table, he should also choose random values. Okay, understood what I'm saying? So otherwise, simply taking common passwords will not be enough. Understood what I'm saying? That means he should generate so many, even more passwords, more different types of passwords. Not only the meaningful passwords, non-meaningful passwords also he has to take, so that for creating such a big database of hashed values. It's only for increasing the complexity of the attacker who is using rainbow attack over this obtained password file. Okay, that's why they are using this particular salt. And generally pepper is not required, but this is only a concept where if somebody wants a particular web server or some particular security providing, people want it to add extra security to this, then they put one more concatenation, which is a secret value. But there is a problem always whenever you put a secret value. Why? Because where do you store this again? You cannot store in the password table. If you call it a secret table and put in the password table, it doesn't make sense. Somebody is getting the password table, he got the secret value. No. Okay. So that's why then if you use the pepper, then you have to think about where to store it. Because whenever you give access, no, you give the password. Let me in. My system will take the password, add the pepper salt, because salt is already inside the system under my username. No? We'll take the salt, add it, hash it, and see, oh, it's correct. Understood what I'm saying? Now there is another important thing. Not only that, if myself and Saurabh has the same passwords, okay, but under our usernames the salts are different. Understood? So the same passwords if we choose also, its corresponding inside hash values are different. Otherwise, what will happen? The hackers will understand that, oh, these two are same hash values. That means these two users are using the same password, or maybe my different accounts can be like that. No? Two different accounts in the same web page. Two accounts is using the same password. That's an information leaked, right? So that way also salts are very useful. So for randomizing it, when you see something, it will confuse you. Randomizing salts are also used. Okay, particularly to randomize whom? The attackers, right? That's it. Any other questions? No, hash value is another. You may get it. You can try into Windows system. You go. There is something called SAM file. Okay, go and try to. It's not directly. You cannot access the hash file. You can use some techniques to access the hash file. You get the hash file. You go come here and type the hash file. Okay, and that is again being hashed. No, the process will not end. When you type the hash file, inside what is the problem? Whatever you type, it will hashed. It will hash it. When you hash it, it's something else junk. It's not in the table. It will not give access to you. It's a different message. It's a different password. That's what I'm saying. It will not give access to you. For what? Exactly to randomize whatever output you have, so that somebody who is trying to attack this one, they'll not get a clear cut meaning or something like that. So like I told you, I have same accounts, but same password, but different hash values, right? And also to create this rainbow table, it is computationally difficult also. Right? He has to generate so many passwords and its corresponding salts to generate hash values. I'll stop here. There's only a very small amount of information, and lots are connected. Okay. Pepper is unique for the whole password database. It's an optional thing only. It's not required, but nowadays I can say you that if you take a large size salt, it's secure actually. Salt should be 128 bits or more. So how many salts will be there? 2 raised to 128 salts will be there. Understood what I'm saying? So the salt size is also significantly larger. It will give you enough security, but still people come with different ideas. You want to put one more secret value and so on. But the problem is when you call the next parameter secret, where do you hide it? Secret means it should be secret, right? So people say that you can put that secret value in some particular web application code, but the attacker knows somewhere in a web application code, he'll search there also. Or otherwise, where do you put it? Somewhere you have to put it, right? so that we cannot manually give the salt, sorry, pepper. So that's an optional thing, but still you can explore it. It's a nice thing to explore. Okay, how this pepper is maintained. Is any website is using a pepper or not? Salt is big. See, nowadays every website is using salt. Keep in mind. Without salt, it's over. Rainbow table attack. Please. Salt is one of the best ways. Only the thing is, salt you have to take bigger size. It's secure. There is no disadvantages. Only the to get an advantage over this rainbow attack, they have introduced salt. Only the thing is, you have to generate random value and attach with the password. But I think that's not a big problem, right? That database has enough space to store all this information. Okay, there is no negative from that side because storage is not a problem in web servers or in a laptop. Any users, any number of salts you can store. Okay, only there is a benefit that it is resisting, or to some extent it will resist the rainbow table attack.